Hello, welcome back to my channel, Logical Literate. This is part 5 of the Raspberry Pi Arduino communication series. In this video we're going to be testing the communication from the Arduino to my computer, simulating the Raspberry Pi over a router, over Ethernet. The Raspberry Pi will first send a message to the Arduino will receive the message, and then respond back with the same message back to the Raspberry Pi. On my computer we'll see the Python code print out, I sent something, and then I received something, to show that our echo on the Arduino is working properly. So before I show this working, I actually want to do a quick recap on the two programs and show their similarities and their differences. So on the left we have the Arduino program, on the right we have the Python program. At first glance you'll notice that the Arduino program is much longer. It's about 110 lines of formatted code versus about 36 lines of formatted code. You'll also notice that it's a lot more structured. This is essentially C code over here, and this is Python obviously. So there's a lot more semicolons and curly braces and stars and all that kind of thing on this side, whereas over here it's a lot less scary formatting. Because the Arduino program is acting as an echo, we have the IP address that we're listening to, and we have the IP address that we're sending to, as well as the heartbeat packet defined and a couple of time constraint things. As we get lower in the code, we notice that we have two generic functions. One's called txPacket, and it's used for transmitting packets, and one's called checkForPacket, which is used for reading packets. Then we have our typical Arduino setup function that just essentially sets up the Ethernet handle. And then we have the loop function that every 2 seconds calls receive heartbeat. The receive heartbeat function essentially checks for the packet, and if it gets a packet, it forwards that packet back using the txPacket function inside of the send heartbeat. On the right hand side you'll notice we have one function here, and it's called with an argument of 8000. That's the port number that this process will be listening on. We also have the target IP address, which matches my IP address in the Arduino. The target port matches the my port in my Arduino. Then we have a while loop that basically runs forever. What it does though is it increments a count, it generates a random number, it packs both of those into a structure, sends it to this program. This program runs through its reception of it, rebuilds the packet here, and then transmits the packet back to this program, where this program will be waiting here to receive the data, unpack it, and show that it received it. So let's go ahead and show this thing working. I've already got the Arduino set up connected to my router, and all I have to do is run this. You can see it says I sent 0, received 0, 32, sent 160, received 160, sent 281, received 281. Pretty obvious what it's doing here. On a more congested network, you could possibly use this to see what UDP does when stuff gets congested. You may see numbers that don't match. You may see numbers that are out of order. You may see other things like that. But because this is a network that only this PC and the Arduino are on, there's not a lot of congestion, and everything flows very cleanly, and there's no drop packets or any of the negatives that come with using UDP. So now I'd like to show you Wireshark. Wireshark is a nice tool for monitoring your network activity. When you open Wireshark, you'll see a window like this, and you'll see all of the different adapters that you have on your device. For us, we're going to be looking at the Ethernet because my PC is wired into the router. If you're connected via Wi-Fi, you'd want to select the Wi-Fi option or whatever other option you may be using. So when you go into Ethernet, you may start to see numbers and messages starting to appear in the window. This is a bunch of DNS. I won't really go into detail about all these messages, but just know that anything that your computer is doing over the internet or over a network, it does, and you can see inside of Wireshark. But to hide all that other stuff, we're going to first say that we want a filter of UDP, and we want the address to be equal to the other thing's address. We'll go ahead and implement that filter, and then we'll put this over here. And then we'll go ahead and run the program again, and what you'll actually see is the network packets pop up on here of what I'm sending, and then you'll see the network packet pop up of what's being sent back, and so on. So let's go ahead and run this. There's my packet that I sent, there's a packet that came back, there's the next one I sent, and so on. Now you notice some of these say malformed packet. Sometimes when you send to a low numbered port, or a specifically numbered port, Wireshark tries to be smart and decode the packet in what it thinks that port's protocol is supposed to be. Really, you can use any port as long as it's available on your machine, but some ports have been essentially reserved for certain protocols. For instance, port 22 is very common for SSH, port 80 is very common for unencrypted web traffic, port 443 is what HTTPS goes to. So there's certain ports that are very standard ports for certain protocols. Here we're in the high numbers. Once you get outside of 2000, that's kind of considered free territory. Anything less than 2000 is generally reserved. But like I said, if it's not being used in your device, it doesn't really matter if it's reserved or not. So as you can see, the packets are flowing through the network. If you were to run this program and you didn't see anything happening here, you might be able to come over here, take off your filter, and see that. Go ahead and disable this so we're not flooded with all this UDP traffic. So you may come over here and you may notice that you get things like destination unreachable. This tells you when it's going from your IP address to the other IP address that the other device sent you a message to your machine, and your machine is responding with, hey, I can't find a process that's on my machine that's at that port number, so I can't deliver it. So I'm going to tell you via the ICMP message that it's unreachable. That's a good way to be able to troubleshoot any issues you may be having, is kind of knowing what the opportunities are for messages here. Like I just described, ICMP messages may pop up. You may also see no IP address. You may want to filter just for your IP address using ip.adder ==, and maybe you want to just filter for the other thing's IP address. And you'll notice that if we hadn't sent all these messages to it, you would see only this ICMP message, and you would say, oh, okay, so it's trying to contact us, but we told it we can't route the message, so we know that our program isn't running. Oh, what if we run our program? Now we can see that our program's running because we're seeing messages go from 2 to 100 and 100 to 2. You can also see the ports here. One more cool thing is you can actually pop open the data and see what the bytes are that are sent. So if you need to troubleshoot maybe your byte order or your byte alignment, you can say, oh, okay, it's 4 bytes, but I was expecting it to be 3 bytes. There must be a padding byte in there. Or, oh, if I take this and I use the calculator to decode what 0500 is and what 3A00 is, then, oh, maybe the bytes are swapped. So now I need to change my byte order by putting in a different character in here. And you can figure out how to do those characters by just looking at the struct library definition on their API page on the Python website. But that's kind of a general overview for testing this kind of stuff and getting messages to flow back and forth. If you found anything in this video helpful, go ahead and leave me a like, maybe a comment in the bottom if you have any questions, and also subscribe. But until next time, thanks for watching.